very sad when it comes to number 36 because I did number 36 and I deleted it. I permanently deleted it off my tablet by accident. I'm so sad. Matter of fact, wait, I'm gonna see if it's in my storage somewhere. If not, then I'll continue. No, it was not uploaded on my Google Photos. So, doing it again. A sample of 153 university students who recently moved off campus were polled to see whether they agree that off-campus living is preferable to on-campus living. In addition, each was asked how many people live in their current off-campus residence. The results summarize the following contingency table. So you have here your survey response, which is agree, no option, disagree. And then you have the number of people that you currently live with. 1 person, 2 person, 3 person, right? Perform a test of independence using the alpha level of 0.05 significance. What do you conclude? All right. So yes, we're going to do the 5 steps of hypothesis testing soon. But when it comes to the chi-square and the correlation coefficients, I always want to compute the test statistic first because it takes more time than when it does with the compare means tests, such as the z-test, the t-test, and so on and so forth. So let's compute our test statistic using the chi-square formula such that it is the sum of the squares of the difference between my observed frequency and my expected frequency, then that is divided by my expected frequency. To find the expected frequency, we're going to multiply the row totals and the column totals and divide it by the overall totals. Each data value will have its expected frequency. But before we do that, let's find the row totals and the column totals. For my agree option to my survey results, if I add up my values 38 and 40 and 33, that equals to 111. For no opinion, if I add up 2, 7, and 12, that is 21. Once again, for disagree, add up 2, 7, 15. 2, 4, and 15. That's going to give me 21. When I add 111, 21, and 21, that gives me 153, which is my overall total. Well, I keep messing up my numbers, just so you know I'm tired. For the column of living with 1 person in your off-campus residence, that is going to equal to 44. For living with 2 people in your off-campus residence, that is going to equal to 49. Shouldn't put that there. When we add up 3 people that you're living with in your off-campus residence, that is going to be 60. 44 plus 60 is 104. 104 plus 49 is going to be 153, which is the overall total. Now, what we're going to do is we're going to find the expected frequency for each. Let's find the expected frequency for a survey response answer of agree, and they have 1 person living in their current off-campus residence. So the row total is 111. The column total is going to be 44, and we're going to divide that by 153. So 111 times 44 divided by 153. We're going to round that to 32. Let's put that in parentheses, 32. Continue the same pattern. That is going to be the row total of 111 times the column total of 49 divided by the overall total of 153. We take that number and we're going to round it to the nearest whole number. So that's going to be 36. Repeat the same process again. Row total of 111 times the column total of 60 divided by the overall total of 153. And that's going to be 44 when I round to the nearest whole number. We're going to do this 3 more times. And the reason I say we're going to do this 3 more times, although we have 6 cells left, is because the row totals for the next 2 rows are the same, which means when I find the expected frequencies, they're going to be the same for those as well. If you look here, the row total is 21. The column total is 44. So 21 times 44. And then we're going to divide by the overall total 153. Let's round that to the closest whole number. That's going to be 6. For the next one, it's going to be our row total of 21 times our column total of 49 divided by our grand total of 153. Round to the closest whole number. That is going to be 7. Let's perform that one more time. That's going to be our row total of 21 times our column total of 60. And we're going to divide that by 153. And we're going to round that to 8. And we're basically doing the same operations again for the third row. 21 times 44 divided by 153, round to the nearest whole number. It's going to be 6. That's going to be 7. That's going to be 8. All right. Now we can compute our chi-square test statistic. It is the sum of your observed minus your expected, that quantity squared, divided by the expected. So for the first cell, agree in 1. 38 minus 32 is going to be 6. So it's going to be 6 squared divided by 32. 40 minus 36 is going to be 4. So it's going to be 4 squared divided by 36. 33 minus 44 is negative 11. Negative 11 squared divided by 44. No opinion and 1. That is going to be 2 minus 6, which is negative 4. Negative 4 squared divided by 6. No opinion in 2. 7 minus 7 is 0. 0 squared divided by 7. No opinion in 3. 12 minus 8 is 4. 4 squared divided by 8. For disagree in 1, it is 4 minus 6, which is negative 2. Negative 2 squared over 6. We're going to have 2 minus 7, which is negative 5. Negative 5 squared is going to be divided by 7. Plus, we're going to have 15 minus 8, which is 7. 7 squared divided by 8. After that, we're going to square the tops. After we square the tops, as we did here, we're going to divide each of these, and we're going to round to 3 numbers after the decimal. Let's go ahead and do that. I'll do the first one. 36 divided by 32 is going to be 1.125. And I'm using my calculator. 16 divided by 36, round to 3 numbers after the decimal, 0.444. Continue the process. All right, once you divide and round all those 3 numbers after the decimal, you're going to add all those values up. And when you add that up, we get the test statistic of 19.349. All right, guys, let's go into our 5 steps hypothesis testing. We already know this is a chi-square test for independence. So when I write our hypothesis, the null and the alternative, we're going to say that survey responses are independent from number of people and off-campus residents. If it's independent, that means there's no relationship. And then for my alternative, we're going to say the survey responses are dependent on, I wrote from here, or independent, yeah, I was right, on the number of people in off-campus residents. Okay. Step number 2 is we want to find the critical values. We already know this is a chi-square test for independence. The alpha level in this case is 0.05. And we need to find our degrees of freedom before we find our critical values. To find the degrees of freedom, it is the number of rows minus 1 times the number of columns minus 1. This is a 3 by 3 contingency table. 3 rows, 3 columns. So it's going to be 3 minus 1 times 3 minus 1. That's going to be 2 times 2. 2 times 2 is 4. Now, with the alpha level, my degrees of freedom, I can find my critical values. Remember that when it comes to a chi-square test, whether it's goodness of fit or a test for independence, it is always a right-tailed test. Degrees of freedom 4. The alpha level is going to be 0.05. The critical value is going to be 9.488. Okay, you guys have that. 9.488. Step number 3 is our test statistic, which we already calculated. That's going to be 19.349. So therefore, I can go to step number 4. Step 4, which is decision time. Drew the wrong curve. My curve is skewed to the right. The critical value is going to be 9.488. Remember, the minimum value for chi-square is 0. If our test statistic falls in a highlighted area, we reject the null. If it does not, do not reject the null. $19.349 will fall somewhere over here to the right. Because it falls within our critical region, we're going to reject the null hypothesis. So there is enough evidence to conclude that survey responses is dependent on the number of people living or in off-campus residence. I kind of didn't write that correctly because I'm rushing, but we will say there is enough evidence to conclude that survey responses is dependent on number of people living in off-campus residence. Alright guys, that is it for number 36. Although it's my second time doing it, but I think this recording is better than the first one. Longer too. No, same amount, same time. Alright guys, See you soon.